Hi everyone. This video is about the simplified structure and functionality of a nuclear power plant, in our case a pressurized water reactor. Here you can see the rough structure. First of all, let's take a look at the reactor building. There's a large boiler with water in the reactor building. On the one hand, there are radioactive fuel rods and control rods in this water. The fuel rods contain radioactive uranium-235 atomic nuclei. These disintegrate. This creates free neutrons that are very fast. However, as long as the gray control rods surround the fuel rods, the free neutrons are simply picked up by the control rods. This prevents a chain reaction. If you want the nuclear power plant to produce electricity, you remove the control rods between the fuel rods. So-called heavy water is now located between the fuel rods. But what is heavy water and what is the difference to normal water? Water consists of H2O molecules. That means 2 hydrogen atoms and 1 oxygen atom. Normal water only has hydrogen H1 atoms in the water molecules. That means hydrogen atoms with only 1 proton. Heavy water has hydrogen H2 atoms. That means hydrogen atoms with 1 proton and 1 neutron. With the help of the hydrogen H2 atomic nuclei, one can now slow down the fast neutrons that are created after a decay, so that they are so slow that they can split further uranium-235 atomic nuclei. Now a chain reaction arises. New neutrons are now released per decay. These hit further uranium-235 atomic nuclei and split them, and more neutrons are released. Each time it decays, energy is also released. This makes the fuel rods extremely hot. The heavy water in the left primary water circuit is also heated very strongly by the hot fuel rods. The water line of this primary water circuit leads through a water tank of the second middle water circuit. As a result, this normal water is also heated there so much that it turns into water vapor. If you now open a valve, the hot water vapor flows through a turbine which starts rotating. The turbine is connected to a generator that generates electricity. The electrical current is then passed on via high voltage lines. The hot water vapor now hits a third water pipe. As a result, part of this third water pipe is heated, and then the water in the water pipe also turns into water vapor. The water vapor can then escape upwards through a cooling tower. The distinctive white clouds are created. So that the nuclear power plant does not get too hot and radioactive material can escape, it is extremely important that the water circuits are cooled. In addition, a nuclear power plant is often located on a river or the sea. Cooled water is directed towards the middle second water circuit. This is cooled down, and the cooled water in the second water circuit now cools the water in the first water circuit on the left.